Okay, let's get moving. My name is Miguel Lavalle, and I'm the Neutron PTL for the Queen series.
Hi, morning everyone. My name is Armando Migliaccio. I work for SUSE, and I've been the Neutron PTL for the Mitaka, Newton, and Okata release. And in between, we have Kevin, who unfortunately couldn't be with us today.
So what we're going to be doing today is giving you an update of where the Neutron project has been over the past cycle and where we see it going over the next 2 cycles. We're going to do a little review of what Neutron is. It's officially called the OpenStack Networking Project. And our mission is to implement services and associated libraries to provide on-demand, scalable, and technology-agnostic network abstractions. And as you can see, we have a mascot, and I'll put some stickers here. So at the end of the presentation, come and get your Neutron sticker for your laptop. So originally, when OpenStack started, all the networking services were embedded in Nova, and that led to the realization that we needed to give users control over the network technology, more control over the network topology, more control over the technologies to be used for networking, and more control over service insertion. So that led to the creation of the OpenStack Networking project. And we, of course, we wanted to provide a multi-tenancy and scalability. This is a high-level description of what's the OpenStack networking architecture. And essentially what we have is really in its essence, Neutron is an API. It's an API server. And that API server is pluggable. So you can always plug different backend technologies. So that's what we are trying to depict there. And that combination of the API plus a plugin, that's what creates Neutron. And then we have the backend that can be in the case of the reference implementation is agents based. We have a number of agents that run across the different compute nodes in the deployment, and those agents instantiate the networking topology and the networking abstractions in the different components of the deployment. And that's what the reference implementation does. And there are other plugins that use different approaches. Many of them use an SDN controller approach, and essentially they do the same in the deployment.
So yeah, I mean, to continue on this high-level overview that Miguel has started, for those of you who like a refresher, especially this early in the morning, Neutron goes back all the way to the Diablo days. And started as an incubated project back then to become a core project in Essex. Over the years, we've gone through a tremendous growth. In Pike release, we've had over 200 contributors per cycle, and over 1,000 contributors over the lifetime of the project. The latest user survey results show that Neutron is pretty much ubiquitously deployed in any OpenStack cloud. That 95% is obviously an aggregated number. As Miguel mentioned, Neutron offers a pluggable framework where you can have multiple backends that can provide networking services. So whilst, again, Neutron itself is deployed widely in OpenStack clouds, the fragmentation across what runs the OVS agent-based architecture versus other backends, it shows that the majority of deployments out there are OVS agent-based, but there is quite a bit of traction with other backend solutions like Contrail, NSX, Midonet, and so on. And to this point, Neutron itself, could be considered, yes, as an API abstraction that tries to provide self-service capabilities when it comes to network virtualization and software-defined networking. But in the end, it's also a a community. And as such, a community that obviously works on delivering software by means of projects that try to organize themselves in order to have an orderly delivery of software assets. And to this aim, we came up with this concept of what's so-called like Open Neutron Stadium, that includes a number of correlated software projects that are overseen by the Neutron core team. And with this concept, we try to provide architectural guidance to networking initiatives, reviews into how APIs that are being discussed and agreed on provide a cohesive and well, again, I hadn't had much coffee this morning. Consistent, that's the word I was looking for. Consistent API experience when using Neutron as a system, as well as the less sexy day-to-day activities that have to happen in software development lifecycle, like release management, dealing with gate issues, and so on and so forth, documentation, and so on and so forth. So the idea is to again group these initiatives together under a single effort that tries to again provide this consistent experience, going from documentation, testing, release management, upgrade strategy, and this software ends up being again provided by the Neutron overall system, and it can also be consumed by a unified OpenStack client and API bindings. The idea, though, is that all these initiatives must share a fundamental design tenet, that the stack that underpins the software system must be open source from the ground up. And in a nutshell, this statement summarizes what I've been saying is that we tend to consider initiatives within this umbrella of software initiatives as those that follow the practice that have been established by the Neutron core team. So to go in a little bit more detail, the status of the union is such that we have a number of backends that we consider being part of the Neutron initiative that span from solutions like Midonet, OpenDaylight, OVN, and Backpipe, as well as other API initiatives that provide high-level services on top of the well-known like L2 and L3 functionality that were part of the initial definition of Neutron as a project. So we have support for BGP VPNs, dynamic routing. We have firewall as a service as well as service function chaining. All right, so I'm gonna hand back over to Miguel to deep dive into what we've been up to.
So we want to share with you the things that we worked on during the Pike cycle, and essentially we did a series of operational improvements. We placed a lot of emphasis in supporting zero downtime upgrades from Okada from the previous release. We reduced the memory footprint for the metadata agent. As you may know, we have an OpenFlow-based firewall now that was implemented 2 or 3 cycles ago, and during Pike we spent a fair amount of time improving the stability of that. We also did a good amount of work with pushing notifications, and what that means is that the L2 agents request information from the server, and what we did was to change that to a push model from the server. And what that allows us to do is to scale better, because essentially when we don't have storms of L2 agents requesting information. It's the server who controls the pace and the rate of sending information to the agents. And now the agents cache that information. We change the API from the agent point of view to cache that information that is being pushed to the agents. And it can be consumed at the pace of each one of the agents. We spent some time also providing finer-grained quota details available. Prior to this effort, essentially if you show your quotas, essentially you could see the limits, the quota limits that you were assigned to the different resources. Now with this improvement to the API, you can not only see your limits, but you can also see the consumption that you have against those limits and those resources.
Yeah, and this is something that's consistent with other OpenStack APIs like Novas and Cinder. So we aligned with those projects as well.
Yeah. We have a tagging mechanism. We have a tagging extension, and essentially what that allows you is to assign a tag to different resources. And a tag is an arbitrary string that you can use to classify your different resources. Prior to Pike, those tags could only be assigned to networks, ports, and subnets, and now we have extended that to all the broader collection of resources in Neutron.
Yeah, if I can add here, this mechanism is also consistent with other tagging mechanisms that are available in other OpenStack projects. One thing that I'd like to stress here is that this tagging mechanism is to be used only to apply user level metadata to instances. So this is a mechanism that's not pretty much is independent from the backend. So the backend actually does not have access to metadata, to tagging information associated to resources. So it's not like you as a user would apply tags on like networks, and those tags will be visible to like a Neutron plugin, a Neutron backend, and drive behavior changes through that way. So it's just as a mechanism to be used for higher level layers on top of Neutron, like like a container orchestration engine, to drive behavior in the higher level. You sound surprised. You look surprised. No. But yeah, that actually was one of the design principles behind the whole tagging mechanism. We didn't want to allowing the tagging mechanism to become a workaround to basically influence backend behavior that would prevent portability pretty much from one platform to another.
So we also merged another extension during the cycle. That's a data plane status, and essentially what that allows is for external frameworks that interact with the data plane, that allows to ports to assign a data plane status attribute. And what the intention is that external frameworks interacting with the data plane can indicate whether that port is working from the data plane point of view. Again, this is external to Neutron. We only allow what we enable here is the API, the extension to the API, and the assignment of that data plane status to the ports.
And yeah, I mean, this is an idea that stemmed from a cooperation with the OPNFV foundation community, where the idea is that Neutron can only go so far in assessing what the well-being of the overall system is, and by providing this hook mechanism, external parties, like for instance OpenStack Doctor, if you're aware of this initiative, can go and provide further insight into the status of the infrastructure and trigger like self-healing actions or things like that.
So we also added a control of the network MTU to projects. Now you can control the size of your MTU in the different networks. Yeah. And
that's also pretty handy actually, because prior to this, the MTU was already a read-only attribute for the network, and you as an operator could say, okay, I mean, I may want to have like jumbo frames throughout my infrastructure, but that was too rigid of a configuration that prevented certain use cases where maybe like your web workload, okay, was sitting in your data center, and you would have full control over, the path MTU. But then, as soon as you go and cross the north-south boundaries, things get ugly. So by that mechanism, we provide a finer-grained capability to tenant users to control the size of the logical networking MTU.
We spent some time doing also level 3 improvements. Specifically, we created a new DVR deployment model where we can centralize floating IPs in those cases where the port is not bound to a specific port. And so we centralize the floating IP, and we maintain the east-west communication distributed. And the point here is that we wanted to support a specific use case.
Yeah, I mean, and maybe it's probably worthwhile spending maybe an extra moment on this, because DVR is as complex as it is, and people may think, okay, why are you giving me more complexity here? And yeah, the use case here stems from the fact that whilst in the default scenario, floating IPs are decentralized to compute nodes, which is a good thing, because again, you want to be resilient to potential failures of the network node. At the same time, that imposes a constraint and a requirement on the underlying data center fabric, where your compute nodes need to have connectivity to the external network. And in some circumstances, this is not possible. So by relaxing that constraint, we effectively are enabling certain deployments where compute nodes don't have external connectivity, and thus you can yet get the benefits of distributing east-west traffic and avoiding the network node as a choke point, and yet use it and leverage it for floating IPs. So it's combining the best of both worlds to some respect, and it's something that you'll have to enable explicitly.
So you might remember that a couple of cycles ago we merged the functionality for routed networks, and essentially with routed networks we are trying to go beyond the constraints imposed by a single unified L2 domain to allow a single network to support a large number of ports. In that scenario, each segment that makes up the network requires its own DHCP agent support. And what we need for in the Pike cycle is to enable the DHCP agent support on other segments. So now with this, not each segment requires its own DHCP support, but can be support from another segment. Also, several cycles ago, we merged the DNS integration functionality, where essentially we allow tenants to assign a DNS domain to networks and a DNS name to ports, and publish that to an external DNS service like Designate. What we did in this past cycle is to also enable DNS. Actually, the slide is wrong. We allowed DNS domains per ports now. So now the DNS domain, now a port can have both a DNS domain and a DNS name, and you can publish that information to the external DNS service. From the point of view of quality of service, we also implemented a number of improvements. We support a direction parameter for bandwidth limit rules. So now you can have inbound and outbound limit rules for direction definition for those rules. And we implemented those in the case of OBS and Linux Bridge. We have now a new, we also implemented an extension to let you know the drivers that are loaded for in the backend for quality of service, the different drivers for quality of service in the backend. And we also enable you to define a quality of service policy as the default for all the networks created under a project. And finally, we now, when you assign a quality of service policy to an external network, that applies to the external router ports, whether this is under DVR or not. From the stadium efforts, stadium project efforts, in the case of Backpipe, native client support was added to Backpipe. From the MiddleNet point of view, OSBIF support was added. OSBIF is a joint initiative between Nova and Neutron to provide better support to the BIFs used by instances, and that support was added to MiddleNet, and the monolithic plugin was deprecated. From the point of view of OpenDate Lite, they added native DHCP support, quality of service version 2, and ceilometer support. And finally, in OVN, SSL support for OVN database connections.
Yeah, I mean, here, just to be a little bit more detailed, this is obviously the Neutron side of the OVN integration that had this effort being done, as well as other minor things like support for native DHCP, DNS, and metadata support. Right, so as just going back, obviously over the past cycles, it might seem that we've focused mainly on L2 QoS and a few bits and pieces in the various stadium initiatives. And whilst we were, we had a much grander scheme over the past few years to conquer the networking world, we've become a little bit more nimble to focus on smaller areas due to how, contributions have evolved over the years and taken some of the key contributors to the project in other initiatives like Kubernetes, for example, or Courier and so on. So looking at Queens, we would end up continuing on this trend of trying to be more nimble and focused on, first and foremost, on stability and community-led improvements, like trying to embrace Python 3 once and for all. Again, solidify our ability to deliver on a fewer set of use cases, but in a rock-solid fashion by improving our testing coverage. And also there is this initiative that it's primarily a housekeeping task, but with the introduction of the stadium and the decomposition of the Neutron code base into individual initiatives, that has the benefit of enabling more innovation. There is this problem of trying to, again, tying things together in a way that they can rely on stable interfaces and avoid breaking each other all the time. And this is where NeutralLib comes in. It's this initiative of defining those stable interfaces that would allow these components to come together and work well together over time, over the release life cycle of the project. And this has been an ongoing effort. It's been going slowly, and but it's nonetheless proceeding. And that's one of the efforts that contributors of the project are focusing on. There is quite a bit of nut that needs to be cracked in relation to testing and database in the database layer. That's really where the crux of the coupling across the various Neutron initiatives is, and we'll get there slowly but surely. Another area that will it's on track for completing is actually something that pertains to integration between Nova and Neutron. Whenever an operator for maintenance reasons wants to either evacuate a node or simply line migrate one instance from one node to another, there are scenarios like, for instance, if DVR is in the picture or not, or you may have different backends, you may end up using one backend over another. There may be reliability issues in how bulletproof the line migration operation is. And by the introduction of multiple port binding, we can have a fine-grained control over the state machine of the line migration operation, and thus make the line migration operation itself a little bit more resilient and potentially allow for better rollback. In case you always look like I'm talking like
I'm paying attention.
Good. So yeah, jokes aside, make the whole operation more bulletproof and allow for potential rollback in case things go wrong. In case, for instance, the node that you're targeting as a target of your line migration for whatever reason experience a failure, and thus you can again bring the VM back on the source node and keep everything alive and kicking and happy.
I would like to add that we're going to see now future slide that we are working together with Nova. So this thing is being worked on both sides right now.
Right, and it's somewhat related to multiple port bindings, but also like an effort related to OSVIF. I don't know if you want to mention something about it. We actually forgot to highlight that in any of the slides. But OSVIF is also an initiative that's been ongoing primarily in the Nova community that tries to decouple some of the spaghetti code that's in the Nova code base that tie the hypervisors to the networking layer and make sure that, again, you can have a little bit of a more sane approach to networking. I don't know if you want to expand a little bit on that. You're good?
Good.
Right. So again, QoS, it's been something that we've been working on for a while. Up until now, you can effectively apply QoS policies just to regular ports. There is an effort ongoing that aims at targeting floating IP ports and thus achieve quality of service on external IPs as well as fixed IPs. NFV, it's an important use case for networking, and for this reason, we're targeting QNQ support. There's an effort ongoing in introducing QNQ as a type driver, and from then enable QNQ not just on OVS, the OVS agent based initiative, but also on other backends like OpenDaylight or OVN. Another key feature that has been in the works for quite some time is security groups logging. With security groups logging, you can, as an administrator, you can effectively do auditing on what types of actions have occurred in your networking topology to see whether there's something malicious happening, and making sure that, again, your security policies are enforced. And by inspecting the logs, you can do that. Firewall as a service, has come a long way since the V2 conception, and thanks to the firewall as a service team. And I think now it's the main emphasis is on OVS firewall. I don't know if you want to expand a little bit on that. I'm not that super familiar on that.
So essentially, the goal here is during this cycle, there's an API version 2 for firewall, and we are the firewall group is merging that API and the related functionality in the Queen cycle.
Right. So, having a glimpse in a little bit in farther ahead. After Queen's, the Rocky release cycle, we obviously continue investing on QoS as a core feature of Neutron, and the idea here is to do scheduling distributed scheduling taking into account quality of service on a global basis rather than on a granular basis. So the idea is that you can take into account quality of service during the scheduling placement phase, and thus avoid the busy neighbors problem in your OpenStack deployment.
Yeah, I just want to add here that we try very hard to get this into Queens. There's some dependencies on the Nova side that are not going to happen soon enough. So we have a spec both on the Nova side and on the Neutron side for this work. And if you're interested in this functionality, please go look at those specs and provide feedback. There's another chance this cycle to incorporate your point of view.
That's right, yeah. Feedback is always welcome. So actually that's a typo here. That's a routed network rather than router networks. So router networks, if some of you are unaware of them, it's this concept that allows us to break the L2 broadcast domain as a representation of a neutron network, breaking this dependency and again providing the flexibility for operators and users to leveraging L3 fabrics. And to date, this capability is only enabled for tenant networking. We need to obviously close the loop and address the same needs for external networks, and that requires integration with with BGP. And we have Miguel here in his spare time. Is going to help make that happen. But
yeah,
since he's been busy,
I would like to mention here that again we have a spec that I have already discussed with some of the large operators. They were very kind to provide feedback. That spec is up for review. And again, please come take a look and provide us with feedback.
Yeah, because at this point, the external network is effectively still a stretched L2 broadcast domain, and we want to break the dependency as well and leverage the same scalability improvements that have been achieved with the existing router network effort for external networks as well. So one thing that also I started a while back is the introduction of security groups leveraging native OVS support. That's something that, again, it's available today. You can kick the tires on OVS native firewalls in your deployment. However, if you have a brownfield deployment and you want to move from one solution to the other, going from IP tables to OVS firewall, that's not as straightforward. And we have a number of folks in the team working into providing a migration procedure that minimizes the data plane downtime. And the idea is that at some point, as a team, we would encourage people to go and use OVS native firewall over IP tables-based firewall, and eventually deprecate the latter and remove it from the code base. There are a number of requests for enhancements, as we call them, RFEs, that we regularly evaluate as drivers of the project, and we'll provide more details as to what these are. But some that are on our dashboard at the moment, on our radar, are OpenFlow-based DVR, and with these, we mean the ability to do distributed east-to-west traffic by leveraging natively OpenFlow. As you may be aware of, today you can do east-west traffic by means of distributed east-west traffic by means of namespaces and L3 agents. This is okay in some scenarios. However, when, for instance, you think in NFV scenarios where you want to leverage fast path acceleration, like the DPDK, the two approaches are effectively incompatible. And we have an initiative being led by Intel that proposes this enhancement, and we're evaluating how what the impact on the code base is and how easy it is to set up, and things look rather clean, and it may be yet another deployment option that the VR will have for those who, again, are interested in not necessarily using natively OVN and DVR and distributed routing as provided by OVN, but continuing using the OVS agent-based implementation.
I just want to add here that there's already code, a proof of concept code. So if you're interested in this type of functionality, please go look at the patch set and give us feedback.
Right. So let's accelerate a little bit to give time for questions. Again, there will be a link at the end where you can read this for yourselves. Looking at policy-based routing as a mechanism to drive routing decisions based on on source subnets. I think we're a hard stop at 30, right? And also we'll try to piggyback on auto topology, the auto topology mechanism that allows tenants to get network provision without really knowing much about Neutron. We're trying to add enhancements on that concept in order to simplify, for instance, the assignment of floating IPs, or are supporting like multiple heterogeneous network topologies.
So as we mentioned, since we are running out of time, as I already mentioned, that we are working with Nova in the instance migration scenario, providing multiple port bindings, and the idea there is to better support that migration, increase the chances of success of the migration, and also shorten the time that the instance doesn't have a network support. So those are the goals there. Of course, we want as many people as possible to come and join the team and help us implement all this functionality. Tomorrow we are going to have a Neutron Pinpoint session. So please come, give us feedback, how we can improve the project, where do you need more support. And also you can always provide feedback in the Neutron, attend the Neutron IRC meeting. We run this on Mondays 1 week and Tuesdays the following week. And you can always talk to us in the Neutron channel. For those of you who are new to Neutron, to OpenStack networking, we're going to have an onboarding session tomorrow. I know that's today, actually, at 1:50. We're going to have a conversation. We want to know you if you're interested in starting contributing to the project. And again, start attending the meetings and letting us know where you are in the Neutron channel.
All right, so I guess we have a few minutes for questions.
Q&A.
If not, you're free to get coffee. Thank you.
Is the QoS doing shaping or policing?
So it does shaping in the case of, shaping in the case of outbound. It's policing in the case of inbound.
Is there anything planned for OVS performance, the chattiness of Neutron server and OVS, especially in cases when one of them goes down and comes back up? So we regularly get this problem where the port transitions from different states when Neutron server or OVS units start, and they talk back and forth again and again. You rebuild the port again.
Yeah, so the question is, is there any effort in improving the scalability of the protocol between server and agents, especially when agents start up as it used to be, they would go to the server, ask for the desired state, and apply the desired state. Apply changes on the local nodes, and the agent is in charge of to reconcile desired state with actual state. And there has been this initiative, as Miguel mentioned, called push notifications, that tries to address this specific problem, where rather than using a poll-based model, you have a fan-out model where the server pushes state changes to the agents, and agents will look and try to cache that information and do the reconciliation from desired state to actual state that way. We haven't actually received field feedback. If you're can help us with that, that would be great, because again, that is one way that we have yet. Obviously, we can iterate and improve on that re-architecture.
Yeah, the push notification model was implemented at the end of Pike, so it's fairly recent. So if you can provide us with feedback, we'll be more than
And
than glad.
that affects, that has affected just L2 agents with security groups. Similar changes would be required for DHCP and L3 agents. However, we lost a key contributor on that effort, Kevin Benton. So yeah, if there is someone who's brave enough to take that on and continue iterating on it, that would be excellent. Any more questions? If not, thank you
so much, guys.
Thank you for coming.